Hello and welcome to my Paper 2 GCSE Maths walkthrough, and this is for the 2024 exam that you're going to be taking soon. Now in this video I'm going to be doing the foundation tier paper, but don't worry because if you are doing the higher tier I am also going to do a video for that as well, so hopefully that should come out in a couple of days time. So a few things to mention. This paper that I'm doing, it's been taken from Maths Genie. So many thanks to Maths Genie for providing the paper. And what they've done is they've just looked at the topics that haven't yet come up on paper 1, and they've put that into paper 2 and paper 3. So I've left a link to the paper in the video description. So what I would recommend you do is have a go at the paper yourself first, and then come back to the video afterwards and have a look at the questions that you think you struggled with, and I can go through my answers with you. So a few other things to mention. I've got a playlist dedicated to past papers, so I've also left that in the video description. So if you'd like a bit more practice with past papers, please click on that playlist, and I've got past papers from years ago. There's loads on there, and the best way to revise is by just doing past paper after past paper. So definitely recommend you check out that playlist as well. On this video and on all of these videos that I've been doing, I've put chapter headings in. So if you want to skip ahead to a particular question, then you can do that quite easily. Just click on the chapter heading, it will take you straight to that question. And you can see that I've got a scientific calculator as well, so hopefully when I'm going through all of these questions you can see exactly what I'm typing into the calculator and which buttons I'm pressing, and maybe you'll discover something you didn't know before, so I think that's going to be quite useful. And I will also be doing paper 3 for foundation and higher. So hopefully after paper 2 finishes, then the paper 3 predicted paper will be out shortly after. It might be a couple of days for it to all be put together, so please make sure you take a look at that as well. So I think that's everything covered, so it's probably time now we get straight into the paper. So without further ado, let's get cracking with question number 1. So question number 1, change 450 centimetres into metres. So for this question, you need to know your conversions between centimetres and metres. And there are 100 centimetres in a metre. So we will need to divide by 100. So we're going to do 450 divided by 100. And I don't even need a calculator for this question. I know that that is going to be 4.5. So our answer is 4.5 metres. And you can see we don't need to write in metres because it's already given to us down here. Question 2, simplify this expression. So you can see they all have the same terms. So they're all f terms, so we can just add them together. If we've got 3f plus 5f, well that will give us 8f, and then 8f subtract f, well now we're going to be left with 7f's. So our answer is 7f's. We don't need any workings out for this, we can just put the answer in. Question 3, work out 10% of 540. So whenever you're calculating 10% of anything, well you're just dividing by 10. So we're going to be doing 450 divided by 10, and I still don't need a calculator for this. Well, that's just going to give me 54. So my answer is 54. Question 4, write down a multiple of 7 that is between 40 and 50. So for this question, I'm first of all just going to write down my multiples of 7. So 7 times 1 is 7, 2 times 7 is 14, 3 times 7 is 21, 4 times 7 is 28, 5 times 7 is 35, 6 times 7 is 42, and I don't need to go any further because I found a number that is between 40 and 50. So I'm going to say 42. There is one other answer that you could give. If we were to carry on, 7 times 7 is 49, and you can see that 49 is also between 40 and 50. So I could say 42 or 49. You don't have to write this, you only need to give one answer, but I'm just showing you the two options that you could have. Obviously, if we were to do 8 times 7, that would take us to 56, which is clearly too big. Question 5, work out 2.5 squared. So for this one, I could do it by hand, but I think I'm going to use the calculator for the first time now. So all we need to type into the calculator is 2.5 squared, or 2.5 times 2.5, whichever one you want to do. So 2.5, and then our squared button, hopefully you remember that is up here. 2.5 squared, press equals. It gives it to us as a fraction. So we could write that as our answer. You shouldn't lose any marks, but because we've been given a decimal in the question, if we press this SD button, that converts it to a decimal. So that is 6.25. So that is the answer, 6.25. Question 6. A film starts at 7:55 p.m. and the film lasts for 88 minutes. What time does the film finish? So it starts at 7:55, so let's write that down. 7:55 is when the film starts, and it lasts for 88 minutes. So I'm just going to write up here 88 minutes. So the easiest way to do this is just to break it down into easy sections. So I'm going to go from 7:55 to 8 p.m. So I can see that that is 5 minutes long. So if we take away 5 minutes from our total film length of 88 minutes, we're left with 83 minutes. So now we're at 8 o'clock. Now I think I'm just going to go straight from 8 o'clock to 9 o'clock. That's quite a nice easy interval. You can see that's 60 minutes. So if we've got 83 minutes left and we've used up 60 minutes, well, we're now going to be at 23 minutes remaining. So we are at 9 o'clock now. But now we've only got 23 minutes left, so all I can do is I can just go from 9 to 9:23, because I know that that is 23 minutes. So if we take away 23 minutes, we're now left with 0 minutes. So we know the film has finished. So the film has finished at 9:23, and we need to think about whether that's AM or PM, but we can clearly see it starts in the evening, so it's going to be PM. So our answer of what time the film finishes is going to be 9:23, and make sure you write PM, otherwise you will be wrong, or you probably will lose marks. Question 7. A taxi company uses the rule below to work out the cost of a journey. So the cost is £1.50 plus £2.25 per mile. We need to work out the cost of a 6-mile journey with the taxi company. Okay, so the fare, write this down, the fare is going to equal £1.50 plus £2.25 times the number of miles, so per mile, and you can see that we're travelling 6 miles, so it's going to be 2.25 times 6. So let's type this into our calculator. It's going to be 1.5 plus 2.25 times 6. Now notice we don't need to include brackets here. Because of our order of operations, the calculator knows to do the multiplication before the addition. So you could put brackets around the 2.25 times 6 if you wanted to, but it's not going to make any difference. So the calculator is intelligent like that. So if we just press equals, we get 15. So our fare is £15. That's our answer. We don't need to include the pound sign because that's already there. So it's just £15. Question 8. There are some counters in a bag. The table shows the number of counters of each colour. A counter is taken at random from the bag. Write down the probability that the counter is green. So how many green counters have we got in the bag? Well, we've got 3 green counters out of the total number of counters. Well, we can just add up the numbers. So 7 plus 2 is 9, plus 5 is 14, plus 3 is 17. So our probability is going to be 3 out of 17. Okay, let's take a look at part B. Write down the probability that the counter is not blue. Okay, there's a few ways you could do this. You could work out the probability of it not being blue by adding up all of the other colours. Or I can just find the probability of it being blue, which is 2 out of 17, and then just take that away from the total. So, not blue. Well, we know there's 17 counters, so it's going to be 17 minus the number of blue, which is 2, and then that's going to be out of the total number of counters, which is 17. So 17 minus 2 is 15, so it's going to be 15 over 17. So that is the answer. If you did do it the other way, you could have just done 7 plus 5 plus 3, which would have also given you 15. Question number 9. Felicity has 3 bags of sweets, A, B and C. Bags A and bag B have the same number of sweets, and bag C has 35 sweets in it. In the 3 bags, there is a total of 119 sweets. Work out the number of sweets in bag A. Okay, so we know the total number of sweets, and we know the number of sweets in bag C. So to work out what's left over, we can just subtract bag C from the total. So we can do 119 minus 35. So let's just type that in. 119 minus 35, and that gives us 84. So there are 84 sweets in bags A and B combined, but we also know they have the same number of sweets in A and B. So we can just divide this number by 2. So if we do 84 divided by 2, I don't need a calculator for that, I know that's going to be 42. So there's 42 sweets in bag A and 42 sweets in bag B, and the question says work out the number of sweets in bag A, so that's just going to be 42. That's my answer, 42. Question number 10. The diagram shows 2 shapes on a centimetre grid. Find the area of shape P. So first of all, we're going to calculate the area of this triangle. So to calculate the area of a triangle, we do half times the base times the height. That's going to be a half times our base, which is 1, 2, 3, 4 centimetres. This is a centimetre grid, remember. And then we multiply by our height, which is 1, 2, 3, 4, 5, 6 centimetres. So a half times 4 is 2. 2 times 6 is 12. So it's going to be 12, and we've got centimetres times centimetres. So our units are going to be in centimetres squared, but we don't need to write that in our answer line. It's already given to us. So it's just 12. Okay, let's look at part B now. So write down the mathematical name for shape Q. So shape Q, you can see we've got a pair of parallel lines here. These 2 lines are parallel, and also these 2 lines are parallel. So let's just mark that on our grid just to show you what I'm saying. So whenever we've got a shape with 2 pairs of parallel lines, that will by definition be a parallelogram. Okay. Now, there are many types of parallelogram. It's definitely not a rectangle because you can see that these aren't right angles. And also, it's not a rhombus because these 2 side lengths, all 4 side lengths, are not equal. Obviously, these 2 are equal and these 2 are equal, but these ones up here, so the diagonal and a horizontal, are not equal. So it's not a rhombus either. And obviously, it's not a square. So it is just a parallelogram. It's a bog standard parallelogram. Hopefully I'm spelling this correctly. So it's a parallelogram. Right, okay, let's take a look at part C. Find the area of shape Q. Okay, so this time we're going to find the area of the parallelogram. Now, to work out the area of a parallelogram, well, that's exactly the same as calculating the area of a rectangle. So it's just, you can just think about it as a squashed rectangle. So it's just going to be the base times the height. So it's going to be the base, which is 1, 2, 3 centimetres, multiplied by the height. And when I mean height, I just mean the vertical height. I don't mean the diagonal over here. It's just straight up. So it's going to be 1, 2, 3, 4, 5 centimetres. And 3 times 5 is 15. So it's going to be 15 centimetres squared. So I just need to write 15 in my answer. Question 11. Work out 3/8 of 140. So whenever we're working out a fraction of an amount, we can just divide by the denominator and multiply it by the numerator. So we can do 140 divided by 8. So 140 divided by 8, and that gives us 35 over 2. Or let's just write that as a decimal. So that's 17.5. And then we can do 17.5 multiplied by our numerator, which is 3. So just times 3. And we get, if we convert that into a decimal again, we get 52.5. So that's the answer, 52.5. Okay, let's look at part B. Write the following fractions in order of size. Start with the smallest fraction. So there's a few ways you could do this. You could convert them all into fractions with the same denominator. And if you didn't have a calculator, I would recommend doing that. So you can see that all of these denominators are factors of 32. So I would find equivalent fractions where the denominators are all 32, and then just look at the numerators and look at which ones is the smallest, basically. But because we've got a calculator, well, there's a much easier way of doing this. All we need to do is type in these fractions into the calculator, and it will tell us what the decimals are. So in the calculator, all you need to do is, let me just show you this button here, this fraction button on the left. If you just press that and type in 7 and then go down and press 8, so 7/8, press equals. Now originally it gives you the answer as a fraction, obviously it's fully simplified, but if you press the SD button, well, that converts it into a decimal, so 0.875, and the reason I'm doing this is because decimals are much easier to compare than fractions. So now let's do the same with 13/16, so type in 13/16, press equals, press SD, and we get 0.8125. Let's do the same for 3/4. Well, I know what 3/4 is. I don't need that. So 0.75. That's nice and easy, that one. And then finally, 25/32. So 25/32, SD, and then we get 0.78125. So now I have them in decimals. I can look at which one is the smallest. So, well, 0.75 is the smallest. So this one is number 1. So let's write that. 3/4. Number 2 is going to be this one here because it's still 0.7. So that is 25/32. Number 3 is going to be this one here. So 13/16. And finally, the last one is 7/8. And just to one important thing, if you have to write these fractions in order, not the decimals, or if you did convert them into fractions, not the converted fractions. You have to put what they've given you in order. Okay, let's move on to question number 12. So the first term of a sequence of numbers is 17. The term-to-term rule of the sequence is to add 4 each time. Is 92 a number in the sequence? Give a reason for your answer. So what we're doing, we're starting off with 17, so let's just write that down. And the term-to-term rule is add 4, so we're adding 4 each time. So 17 plus 4 is 21, and then the next number will be 25, the next number will be 29, and then 33, and then so on and so forth. So we need to work out, is 92 in this string? Now, I know straight away that the answer is no. So you may have spotted this, I'm not sure, but the key thing here is that we're starting with an odd number and we're adding an even number each time. So that means that we're always going to have odd numbers. So we're starting off with an odd number, and then we've got another odd. Every number is going to be odd because we're adding an even number each time. So 92 is definitely not going to be in the sequence, so we can say no. And the reason we need to give is that the sequence, it doesn't matter how you say it, the sequence is, let me go back to my pen. The sequence is only odd numbers. Sequence is only odd numbers. 92 is even. So anything along those lines would be absolutely fine. You could work out the nth term, and I'm sure there'll be some of you who have done that. So work out the nth term and then use that nth term and set that equal to 92 and work out if there is a value for n that is a whole number. And you would find the answer would also be no, but this is obviously a much quicker way of doing it. And just one other thing, you can see this is only worth 1 mark, so hopefully that gives you an indication that you don't need to go to a lot of trouble to get the answer. Question 13. Anne and George did a test. The total for the test was 75 marks. Anne got 72% of the 75 marks, and George got 55 out of 75. Sorry, 55 out of 75. Who got the highest mark? You must show all your working. So I think let's start with Anne. So Anne What did she get? Well, she got 72% of 75. So that's just the same as 72% times 75. Or if we wanted to write this as a decimal, we can just do 0.72 multiplied by 75. So 0.72 times 75, and that gives us 54. So Anne got 54 marks. Now George, well, we already know how many marks George got. We're told George got 55 marks. So now we can compare the two. Who did better? And it looks like George did better. So I'm quite pleased. The boys did better in this exam just by 1 mark. So we need to say George. George is my answer. And we need to give a reason. Now, leaving it like this, you might lose marks. So how do we know that 55... how do we know that George got higher marks? Well, we have to say that 55 is greater than 45. It might seem, not 45, 54. It might seem a bit silly writing this, but we just want to make sure we secure the 2 marks. Question 14. Enlarge the shaded triangle by a scale factor of 1.5 and the centre of enlargement is O, so at the origin. Okay, so we're starting off at the origin. And what I like to do is I like to pick a point on my triangle. So let's just pick that point. And let's see how far it is from our origin to this point here. Now I can see we're going in diagonals. So I'm just going to go 1, 2, 3, 4. So we're going 4 diagonals until we get to our point. But we're enlarging everything by a scale factor of 1.5. So if we do 4 times 1.5, well, that's going to give me 6. Now, if I start at my centre of enlargement, instead of going 4 diagonals, I'm going to go 6 diagonals. So I'm going to go 1, 2, 3, 4, 5, 6. So now this point is now being shifted over here. But now I've got my first point. I don't need to do that for all 3 points. I can just measure each of the lengths. So you can see that this length here is 2 units. So I'm going to enlarge that by 1.5. So 2 times 1.5 gives me 3. So now my new base is going to be 3 units. So 1, 2, 3. And if we think about our height was 2 units. So that's also going to be 3. So 1, 2, 3. And then we just need to connect these 2 lines. I'm trying to do it as accurately as possible. And I do recommend you use a ruler. But for me, this is absolutely fine. There may have been other ways you could have done this. You could have used vectors. But however you've done it, as long as you've got this answer, that's absolutely fine. Question 15. You can use this graph to change between litres and pints. So we've got litres on the x-axis and pints on the y-axis. Part A, we need to change 10 litres to pints. So we're going from litres to pints. So if we look at litres, that's on the x-axis. Now 10 litres is this point here. So we just read up our graph until we get to the line, which is here, and then read along until we get to the x-axis, which is here. And you can see it's exactly halfway between 15 and 20. So that's going to be 17.5 pints. So it's 17.5, and they've already given us the pints there. Okay, let's look at part B now. Change 90 pints to litres. So this time we're going the opposite way round. So if we look along the pints axis, notice there is no 90 pints. So let's just go home. No, what we're going to do is, if we think about factors of 90, well, I can see that 30 is a factor of 90. So what I'm going to do is I'm going to read off from 30, but whatever my answer is, I can just times that by 3. Because I know that 90 divided by 30 is equal to 3. So let's do that. So if we read across from 30 until we get to the line, and it's not quite halfway, it's I think on that point there. So now if we come down, so if that's going to be 17.5. So this line, well, that's going to be 17 because each of these is 0.5. So there's 10, you can see there's 10 squares and there's only 5 units. So each of these is 0.5. So 15, 15.5, 16, 16.5, 17. So let's just mark that on there. That is 17. So that's for 30, but we want 90, so I'm just going to do 17 multiplied by 3, and let's just put that into the calculator. 17 times 3, and we get 51. So 51 is our answer, 51, and that is going to be in litres. Again, we don't need to write litres because it's given to us here. Question 16. The table shows some information about the colours of cars parked in a car park. We need to draw an accurate pie chart to show the information. Okay, so now this is going to be a bit trickier for me because I'm doing this on a screen. Obviously, you will need a protractor for this question. So what I'm going to do is, first of all, let's work out what each car represents in terms of degrees. So how many cars were in the car park? We're just going to add these numbers together. So 24 plus 16 plus 15 plus 5. That gives us 60, and that's quite nice because 60 is a factor of 360. So if we know that there are 360 degrees in a circle, and there's going to be 60 cars, to work out how many degrees there are for each car, we just do 360 divided by 60, and that gives us 6 degrees. So that means that each car, I'm just going to write this down, each car is equal to 6 degrees. So if we have the black, we know there are 24 black cars, so we can just multiply that by 6. So 24 times 6, we get 144. So it's going to be 144 degrees. We do exactly the same for silver. 16 times 6. 16 times 6, that's 96 degrees. Do the same for white. 15 times 6, well, that's just going to be 6 less than 90, 6 less than 96, which is 90 degrees. And then 5 times 6 is 30. So these should add up to 360 degrees. I'm not going to check it, but I'm just going to assume they do. So now we have the number of degrees for each car. We can measure that. So we put our 0 along this line. So make sure you're reading off the right scale because there are 2 scales on a protractor. So I'm trying to line this up as best as I can. So what are we measuring? 144. So this is 90 round here. 140 is round here. 144, for me, I think it's about there. It might not be perfect. Apologies, I just dropped the ruler or the protractor. So I'm going to get my line tool out and just measure a line from here to here. And now we just need to label that. So that is going to be black. And I'm going to do it in black. So that is black. Now let's go on to the next one. So the next one is silver. So this time I'm going to start off using this line. So I'm going to put my 0 line on this line I've just created and make sure it lines up perfectly. And 96 degrees, well, that's that's 90, that's 100. Oh, sorry, that's 100, that's 95, so 96 is going to be there. Okay, let's get my line tool out again. And if you did want to skip along, I don't mind, I won't be offended. So that is going to be 96, so that is silver. So let me get my grey out just to represent silver. Okay, moving on to the next one. What have we got next? We've got white. Oh, no, I'm obviously not going to be able to draw, write the name in white, but I'll pick a different colour. Right, so let's measure. Okay, just adjust it slightly. Okay, I think I've got that. So what have we got? We've got 90 degrees. That is going to be here. So that is going to be my white. And what colour shall I use for white? These are the big questions in life. So I think I'm just going to go rogue and use orange because there's no orange here. So that is white. And finally, we don't need to measure this last one. This should be, if we've done everything correctly, this should be 30 degrees. So I'm not going to bother measuring that one. So the last one is blue. And I do have a blue colour for that one. So we've got blue here. And we're done. So hopefully you've got something like this. If you're 1 or 2 degrees out, I think there is some margin for error. But obviously try to be as accurate as possible whenever you get these types of questions. Question 17. The accurate scale drawing shows a field. And the field has a real length of 49.5 metres. we need to find an estimate for the real area of the field. Okay, for this question, you will need to print it off. Okay, you will need to print the paper off because we're going to be measuring scale drawings. So what we need to do is, I have printed this off already, and I've measured these lengths here, and this length, so the width of the field is 4 centimeters. So I'm going to write that in here. The width of the field is 4 centimeters, and the length of the field on paper is 9 centimeters. So now we can use this to calculate the scale factor. Because we know the real length and we know the scale length, we can work out what the scale factor is. So we can take the real length, so 49, I'm just going to ignore units for now, so 49.5, and divide that by 9 to work out the scale factor. So 49.5 divided by 9, and we get 11 over 2, which is 5.5. So that's 5.5. So now we know the scale factor, we can work out the real length of the width. So the real width, well, that's going to be equal to 4 multiplied by 5.5. So 4, I'm just going to do times 4, and we get 22. So that's 22, and that is in meters. So 22 meters. So now the area, now we have the width and the length, we can just multiply them together. So it's going to be 22 meters multiplied by 49.5 meters. So times 49.5, and we get 1089, and our units, meters times meters, our units are going to be meters squared. So this is our answer, 1089. Question 18, part A, we need to factorize this expression. So what is the highest common factor of 10 and 15a? Well, that's 5. So we can factor out a 5. We can factor out a 5 from both terms. So if we do 10 divided by 5, well, that will give us 2. And then we're going to have subtract 15a divided by 5. Well, 15 divided by 5 is 3. So it's going to be 3a. So this is going to be my answer, 5. And then in our brackets, 2 minus 3a. Okay, let's look at part B. Factorize fully. Okay, so we need to make sure we fully factorize this. So very similar to the previous question. So what is the highest common factor of these two terms? Well, they both have if we think about the numbers first, the highest common factor of 3 and 6 is 3. So we can factor out a 3. The highest common factor of x squared and x is x. And the highest common factor of y and y squared is y. So we're going to factor out a 3xy. And then in our brackets, if we divide both sides by 3xy, or both numbers by 3xy, 3 divided by 3 is just 1. X squared divided by x is x. And y divided by y is just 1. And then the second term, so we're going to have plus 6 divided by 3 is 2. X divided by x is just 1. And y squared divided by y is y. So here's our answer. So we've got 3xy and then x plus y, 2y in brackets. Question 19. Last season, a football team scored 38 goals, and this season, the football team scored 77 goals. They're much better this season. Work out the percentage increase in the number of goals scored. So how do we calculate percentage increase? So percentage increase. Well, it's the change in the number of goals. So it will be the change in the number of goals divided by the original amount. So the original number of goals scored. So that would be the goals scored last season. So that would be as a fraction. That would be the increase as a fraction, but we need to give it as a percentage. So we just need to multiply our answer by 100. So what is the change? Well, the change is going to be 77 minus 38. And then the original amount, well, that was 38. They scored 38 goals last season. And then we're going to multiply that by 100. So let's type all of this into our calculator. So we've got 77 minus 38, that's the change, divided by 38. And then we're going to multiply all of that by 100. And if I just press the SD button, you can see we get 102.6. I'll leave it rounded to one decimal place. And this is as a percentage. So that's my answer, 102.6%. And I always do a dummy check with these type of questions. Does that make sense? Well, to me it does, because they've doubled, or they've over doubled what they got last season. So 100% increase would be 96, 38 times 2, and it's sorry, not 96, 76, and it's just over 76, so it's just over 100%. Question 20. The height of a building is 310 meters, correct to the nearest meter. Complete the error interval for the height of the building. So whenever you need to calculate the upper and the lower bounds, you always choose half of whatever unit you've been given. So because it's over here, it's to the nearest meter, well, we're going to go half a meter below and half a meter above. It's always half of whatever units. If it said here to the nearest 10 meters, well, we'd go 5 meters below and 5 meters above. So half a meter, 310 minus half is going to be 309.5, and 310 plus half a meter, well, that's going to be 310.5. So we don't actually need any workings out for this question. So the upper and the lower bounds are always half of the whatever units you've been given. Question 21. Work out all of this business. We need to give our answer in standard form. So these are nice calculator questions, because all we need to do is type all of this into the calculator. So we're starting off with some brackets. So if we open our brackets and type in 3.12 times by 10, and then our power button is the one next to the x squared. So if we press that, and our power is negative 6. So whenever I type in negative numbers, I always use this one. This one down here is to subtract something, but a negative number, if you press this here, so it's that button and then 6. So we've got negative 6. Now, a lot of people after that just press the end brackets, but notice at the moment we're in the power, we're in the index up here. So what we need to do, if I delete that, if I press the right arrow key, that goes back down to the normal line. And now if I press close brackets, we've closed the whole bracket here. Okay, and now we're going to divide. And then if I open up my brackets again, we've got 2.5 times 10 to the power of, so this time it's negative 4. Go to the right, close my bracket. So now I've typed in everything. If I press equals, now we've got a fraction here. If I press the SD button, we've got a nice decimal now. So we've got 0, oh, wrong pen again. We've got 0.01248. Now we need to write that in standard form. So our base number is going to be 1.248 because it has to be between 1 and 10. And then we're going to be multiplying by 10. Now, if we're starting off at 1.248, our decimal point is here. So actually we're dividing by 10, but we can still think about it as multiplying by 10 to a negative power. So we're going 2 places to the left. So our power is negative 2. So that is our answer, 1.248 times 10 to the power negative 2. Question 22. 3 buses, A, B and C, all use the same bus stop. Bus A runs every 10 minutes. Bus B runs every 12 minutes. And bus C runs every 14 minutes. All 3 buses are at the bus stop at 11 a.m. What time will all 3 buses be at the bus stop again? Right, okay, so for this type of question, we need to find the lowest common multiple. So the lowest common multiple of our 3 numbers. So 10, 12, and 14. Because we want to know when the next time it is that they're all together. So to do this, we could list out all of the multiples of 10, 12, and 14, and then just look at sort of when they all have the same multiple, but that's going to take a long time. For this question, I'm going to use prime factorization. So I'm going to write each of these numbers as the products of their prime factors. So if we start with 10, well, 10's nice and easy. That's just 2 times 5. 12, well, 12 is 2 times 6, but we can write 6 as 2 times 3. So it's going to be 2 times 2 times 3. This is 12. And then finally 14, well, that's going to be 2 times 7. So now we've written each of these numbers as the products of their primes, we can work out the lowest common multiple. So the lowest common multiple, well, let's first of all start with 10. To be a multiple of 10, it has to be a multiple of 2 times 5. So it has to have 2 times 5 in. So that's going to, anything with 2 times 5 in will be a multiple of 10. Now, to be a multiple of 12, it has to have 2 times 2 times 3. Well, we've already got one of the 2's over here, but we need to have 2 times 2. So we need to multiply on another 2, and also we need to multiply on a 3. So now you can see 2 times 2 times 3 is 2 times 2 times 3. And now to be a multiple of 14, it has to have a 2 times 7. We've already got the 2. It doesn't matter which one we use, but we've got the 2. We just need a 7. So we need to multiply on by 7. Okay, so now let's type all of this into the calculator. 2 times 5 times 2 times 3 times 7. And we get 420. So 420, that is in minutes, remember. Our units were in minutes. So we're starting at 11 a.m. and we're adding on 420 minutes. Now it's going to be a lot easier to work in hours. So 420, we know that there are 60 minutes in an hour. So if we divide by 60, that's nice because it gives us 7. So that is exactly 7 hours until they next meet. So if we're starting at 11, we're adding on 7 hours. We're now at 1800 hours. So 1800 hours, that's exactly the same as 6 p.m. So the time that all three of them meet at the bus stop will be 6 p.m. And there's going to be a bit of a collision when that happens. Hopefully not. Question 23. The table gives information about the times taken in seconds by 20 students to run a race. So you can see here between 20 and 25 seconds, there were 2 students. There were 10 students who took between 25 and 30 seconds and so on. Work out an estimate for the mean time. So notice how it says estimate because we can't calculate an exact mean because we don't know the times. All we know are the intervals. So what we do is the best estimate that we're going to get is by if we use the midpoints of these intervals. So let's do another column for midpoint. So if we think about the midpoint for the first category, 20 to 25, well, that's going to be 22.5 seconds. The next midpoint between 25 and 30, that's going to be 27.5. This one will be 32.5. And this last one, be really careful because this is a slightly different interval. To go from 35 to 45, the midpoint is going to be 40. Okay, so don't assume all of these intervals are the same distance, basically. Okay, so what we're going to do is we're going to assume these 2 people took 22.5 seconds to complete the race. So what is the total time that these 2 people took? Well, we just need to multiply the frequency by the midpoint. So 2 times 22.5, well, that gives us 45 seconds. And we're going to do the same for each interval. So 10 times 27.5, that is 275. 5 times 32.5, let's put that into the calculator. 5 times 32.5, oh, not 33.5, just notice that there, 32.5. And convert that to a decimal, we get 162.5. And finally, 3 times 40, well, that is 120. So we know the total time for each interval. Let's work out the total time for everyone. We just need to add up all of these. So we've already got 162.5 plus 45 plus 275 plus 120. Oh, I think there's something wrong with this calculator. I keep typing in the wrong thing. Plus 120 and we get 602.5, and that is in seconds. So to calculate the mean, we know that the mean is going to be the total time by the number of students. Number of students? Yeah, it is. Number of students. Okay, so the total time we know is 602.5. The total number of students, we know there's 20 students. And if we're not told about that, we can just add up the frequencies to give us 20. So we're going to do 602.5 divided by 20. And we get 30.125 seconds. So that is going to be my answer. 30.125. Now, always do a dummy check. So, does this seem like a reasonable time for the mean? Well, the minimum time, well, it's not going to be 20, it's going to be greater than 20, but it could be like 20.1. So let's just use 20. And the maximum time was 45. So we know our mean has to lie between these two values, and you can see that it does, and it is somewhere in the middle. So I'm quite happy that this would be the right answer. Question 24. ABC is a trapezium. AB is parallel to DC. We need to find the size of angle BCD. So BCD, that's this angle here. So at the moment we've been given these angles just as expressions. So we'll need to calculate what the value of x is first. And to do that, I'm going to use these two angles because I know there's a special relationship between these two angles and they sum to 180 degrees. These angles are called co-interior. So co-interior angles sum to 180 degrees. That's just one of our angle properties. So you've got alternate angles, you've got corresponding angles that are both equal, and there's co-interior angles, so angles that are sort of inside a pair of parallel lines. They always sum to 180 degrees. So we can write this out as an equation. We can say that 2x plus 19 plus 3x minus 6 is equal to 180 degrees. And now we can solve this equation. So 2x plus 3x is 5x. 19 minus 6 is 13. Plus 13. Yeah, 19 minus 6 is plus 13. And that equals 180. Now if we subtract 13 from both sides, we get 5x is equal to 167. And then if we divide both sides by 5, 167 divided by 5, and let's convert that into a decimal, is 33.4. So now we know the value for x, we can substitute that into our expressions. Now we don't need to do that for all of our angles. I'm just going to substitute this value of x into this expression up here. And the reason why I'm doing that is because these two angles are also co-interior angles. So notice how these two angles, just like these ones here, they also sum to 180 degrees. So let's work out what this angle is. So this angle is going to be 4 times x, which we just worked out is 33.4 minus 57. So let's put that into the calculator. 4 times 33.4 minus 57, and we get 76.6 degrees. So now we know what this angle is, we can work out our angle, which is what we need. So this is angle BCD. So angle BCD is going to be equal to 180 minus 76.6, because we know they add up to 180. So 180 minus, I'm just going to press answer, and that gives me 103.4 degrees. So that would be my final answer, 103.4. Question 25, part A. Complete the table of values for y equals 7 plus 2x minus x squared. So I'm just going to write it down here. So we've got 7 plus 2 times x. Well, let's start off when x is equal to -2. And then we're going to subtract x squared. So x, again, is -2, but we need to put that in brackets. So it's -2 squared. And make sure you put this in brackets. If you don't put it in brackets, you're going to get the wrong answer. And I'll show you that with my calculator. So we've got 7 plus 2 times, in brackets, -2, close brackets, and then subtract. And then we're going to open up our brackets again, -2, close brackets, and then squared. And we get -1. So our first value for x is going to be -1. And I actually just want to show you what happens if we take off the brackets. Okay, so we've got -2 squared, but without the brackets, you can see we get a completely different answer. Okay, and it's to do with the orders of operation. So we need to make sure we put brackets around our negative numbers. Okay, these ones it doesn't matter, but definitely when we're squaring, we need to include it. Okay, so you can see we get an answer of -1. Now, save this on your calculator. All you need to do is go into the brackets, and instead of where it says -2, just replace the -2 with -1. So in both instances, replace it with -1, press equals, and we get our answer of 4. So instead of typing out the whole equation again, we can just delete what's in the brackets. Okay, so I'm just deleting the -1 for 0 this time, and we get 7. And again, you can skip along if you want, if you're not really interested in what I'm doing here. You already know this. So I'm just replacing them with the value for x each time. So it doesn't take too much effort. Obviously doing this is a lot quicker than writing out the whole thing again. And yeah, I can't really entertain you any other way. So we get 4, and then our last one, when x equals 4, our y value equals -1. Okay, so we've got our table of values. So now let's look at part B. Now we have to draw this on our grid. So on the grid, draw the graph of y equals 7 plus 2x minus x squared for values of x between -2 and 4. Okay, so when x equals -2, y equals -1. So that is going to be there. -1, 4 is there. 0, 7 is there. 1, 8 is here. 2, 7 is here. 3, 4 is here. And finally, 4, -1 is here. So we've got our points. Now we need to draw the graph. So this is going to be freehand. So I'm going to try my best to do this as accurately as possible, but hopefully you forgive me if it's not up to your standards, or if it's not up to the one that you did on your computer, or if you printed it out. You did that. Okay, so this is the hard part, coming back down. Okay, I'm not as confident going in this direction, but I'm not too pleased. I'm not too pleased. I'm quite pleased with that. That's not too bad. So now, and the reason why you should try and do it as accurately as possible, because usually with these type of questions, you now need to use your graph. So part C, use your graph to find estimates of the solutions of this equation. So notice the equation we've got is almost identical to this equation, but it's just, instead of y equals, it's 0 equals. So what we need to do is we need to find, where does y equal 0? Well, y equals 0 at the x-axis. So let's do this in a different colour. You can see that y equals 0 along this line. Anywhere along this line, y is equal to 0. So we're just looking at where our graph crosses this line. So it crosses at 2 places. So this place here and this place here. So what are the x values that corresponds to? Well, we've got 2, so x is going to be equal to either, I'm going to say that's -1.9, or, well, I think that's about 3.9. And there will be some margin for error on this. You'll probably be allowed within sort of 0.2 of each one. So you might have a slightly different answer, but if you're close to these values, then you probably have got the right answer, and you'll probably get the full marks. Question 26. Josh drove 39 miles from Luton to Cambridge. He then drove 63 miles from Cambridge to Norwich. Josh's average speed from Luton to Cambridge was 32 miles per hour. and Josh took 18 minutes to drive from Cambridge to Norwich, work out Josh's average speed for his total drive from Luton to Norwich. So it looks like his journey's been split up into two. We've gone from Luton to Cambridge and then Cambridge to Norwich. So to work out the average speed, so average speed, well, it's going to be the total distance, and then we're going to divide that by the total time. Because we're working out the average speed for the whole journey. So it's the total distance divided by the total time. Now the total distance, we can work that out quite easily because we know it's 39 miles from Luton to Cambridge and 63 miles from Cambridge to Norwich. So we just need to do 39 plus 63. I think I can do that without a calculator. That's going to be 102. So it's 102 miles divided by the total time. Now, we don't know the total time. We know the time from Cambridge to Norwich is 80 minutes, but we don't know the time from Luton to Cambridge. So, Luton to Cambridge. How do we work? Let's just write out their time, because we want to work out the time from Luton to Cambridge. So, we can just rearrange our formula for speed. If we're trying to work out time, well, time is going to be distance divided by speed. So it's going to be distance divided by speed. And this is all from Luton to Cambridge. So the distance from Luton to Cambridge is 39 miles. 39 miles divided by the speed from Luton to Cambridge. Luton to Cambridge, we know that the speed was 32. So it's going to be 32. I'm just going to put mph for miles per hour. So let's work that out in the calculator. 39 divided by 32. And we get 1.21875. So that's time. So that's going to be in hours. So now we can work out the total time. So total time, well, it's going to be the time from Luton to Cambridge, which we've just worked out, is 1.21875, plus the time from Cambridge to Norwich, which we were told is 80. Oh, I was about to put 80 minutes. Now we need to be really careful here because we've got minutes and hours. So let's convert everything into hours. So to go from minutes to hours, we need to divide by 60. So 80 divided by 60, let's just put that into the calculator. We get 4 over 3, which is 1.3 recurring. So plus 1.3 recurring. So what is the total time? Well, we're just going to do 1.3 recurring plus 1.21875. And we get 2.55. I'm just going to actually, no, I'll write the whole thing down. 2.55208 recurring. So now we have worked out the total time. I can put that into my denominator. So we've got 2.55208 recurring. Okay, so what is the average speed now? So I've got this saved, so I'm just going to do 102 divided by answer, because that was the previous answer in the calculator, and I get a fraction which we can convert into something a bit more meaningful. So we get 39.9. I'm just going to round to one decimal place, so actually it's going to be 40. It's going to be 40.0 because 39.9 would, the 9 would be rounded up. So 40.0, and that's going to be in miles per hour. So 40.0. The units are already given to us, so we can just leave it like this. It doesn't say what to round to, so if you did put 39.97, that would also be fine. So anything, as long as it's the correct answer, would be you would get full marks for. Question 27. Millie invests £2,000 in a savings account for 4 years. She gets 3.9% per year compound interest. Work out how much money Millie will have in her savings account at the end of 4 years. Give your answer correct to the nearest pound. Okay, so we know the initial investment is £2,000. £2,000, and we're going to multiply that by the percentage increase. So a 3.9% increase, if we write that as a decimal multiplier, well, that will be 1.039. That will be a 3.9% increase. Now we're doing that for 4 years. So I could times this by this number 4 times, or I can just raise it to the power 4. So let's put that into a calculator. 2,000 multiplied by 1.039 to the power of 4. Press equals, and that looks about right. So we're getting £2,330 and 73 pence. But we need to give an answer to the nearest pound. And remember, this is the amount of money in her savings account, okay, which is what it's asking for. If it said work out the amount of interest that Millie receives, well, we would need to take away the original investment from the amount here. But it's not. It's just how much money is in the account. So we need to write our answer to the nearest pound. So it's going to be £2,331 because we're going to round up. Question 28. Work out the size of angle BAC. Give your answer to 3 significant figures. So BAC, that's this angle here. And I can see we've got a right angle triangle and some side lengths. So what we're going to use is SOHCAHTOA. So I always like to write out SOHCAHTOA like this. SOHCAHTOA. So from this angle, this is the angle we're trying to work out. From the perspective of this angle, we've been given the opposite and we've also been given the adjacent. So which trig function involves the opposite and the adjacent? Well, it's the tan function. It's this one over here. So we're going to use the tan function. So we can say the tan of our angle. So the tan of, let's just use our symbol theta. So the tan of our angle is equal to the opposite, which is 7.5, divided by the adjacent, which is 12.1. So now to work out our angle, well, we take the inverse tan. So it's going to be tan inverse of 7.5 divided by 12.1. So I'm going to put all of this into a calculator. So here is tan. To work out the inverse tan, you do shift. So it's going to be shift tan. And then in our brackets, we've got 7.5 divided by 12.1. And then close brackets. And we get 31.79. And let's just think about, does that make sense? Well, it does. It's quite a small angle. So 31.79 sounds about right. But just looking at the question, we need to give an answer to 3 significant figures. So 3 significant figures is going to be 31.8 degrees. Question 29. The diagram shows triangle ABC. ADB is a straight line. The size of angle BCD to the size of angle ACD is 2 to 3. So first of all, let's just have a look at what that means. So BCD, so this angle here, and angle ACD, so let's just do that in a different colour. Okay, so the ratio of these two angles is 2 to 3. So I'm just going to write that in here as a ratio. So that is 2 to 3, just to remind me. Now let's have a look at the last part of the question. It says work out the size of angle ADC. So ADC, that's this angle here. So the first thing I'm spotting is that this big triangle, we've been given 2 of the angles, so we can work out this big angle over here, the combination of these 2 angles, just by knowing the fact that angles in a triangle sum to 180. So if we do 180 minus 83 minus 52, what does that give us? So 180 minus 83 minus 52, and we get 45 degrees. So this angle is 45. Now I can use the fact that I know what these ratios are. So the ratio is 2 to 3. So what I can do is if I add these together, that gives me 5. So there's 5 parts. If I do 45 divided by 5, Well, that gives me 9 degrees. So each part is worth 9 degrees. So this angle, well, that's going to be 2 times 9, and 2 times, not 2 times 19, 2 times 9, and 2 times 9 is 18 degrees. And now if I focus on this angle here, well, this angle is going to be 3 lots of 9, 3 times 9, and 3 times 9 is 27. And notice when we add them together, we do get 45 degrees. So now we've been given this angle, and I think this is the one to focus on, because now if we look at this triangle, we've now got 2 angles in our triangle. So we can say that angle ADC is going to be 180 minus these 2 angles. So minus 52 minus 27. So 180 minus 52 minus 27. And we get 101 degrees. So that is our answer. The size of angle ADC is 101. Question 30, and I can see from the bottom this is the last question, so well done for getting this far. So the diagram shows a solid triangular prism. We've been given the dimensions, and the prism is made from wood with a density of 0.6 grams per centimetre cubed. Work out the mass of the prism. So let's just remind ourselves how to calculate density. What's the formula for density? So density is mass divided by volume. Now we need to work out the mass of the prism. So if we just rearrange this formula, well, mass is going to be equal to the density multiplied by the volume. Now we already know what the density is. We need to calculate the volume. So the volume of our prism, or the volume of any prism, is a half times the base times the width times the height. Essentially, what we're doing is we're making a cuboid. So the cuboid is base times width times height. But because we've got a triangular prism, we're sort of cutting it in half. We need to take half of that. So it's going to be half times 8 times 15 times 10. So I'm just going to put that into a calculator. So 0.5 times 8 times 15 times 10. And we get 600. That's quite a nice number. 600. And that is in centimetres cubed. So that is our volume. We know what the density is. So our mass is going to be the density 0.6 grams per centimetre cubed, multiplied by our volume 600 centimeters cubed. So I can just times this by 0.6 and we get 360. And just to check our unit, so we know mass, it should be in grams, and that does make sense because we've got grams divided by centimeters cubed times centimeters cubed. So essentially the centimeters cubed will cancel out and we'll just be left with grams. But that doesn't really matter because we're given the units in the answer. So our answer is going to be 360. So we have come to the end of this walkthrough. So I really hope you found this useful. And just to let you know, I will be doing a paper 3 walkthrough as well. So as soon as the paper 2 exams have been completed, a couple of days after that, I'll post a paper 3 walkthrough to help you with the last exam. So many thanks for watching and best of luck for the upcoming exams, and hopefully I'll see you in the next one. Take care.